So we're just about done talking about human body systems, focusing on how all of these body systems help us to maintain homeostasis, to keep constant conditions, to allow us to live and survive. So we got a couple left. The next one are our body systems that are used for movement. Another term for movement in biology is locomotion. It means moving. And so we'll talk about our skeletal and muscular system here today. So to allow us to move, we have sort of two systems working together. We have our skeletal system. Attached to that are our muscles that we have conscious voluntary control of. And so right now, as you're writing these words, your brain is sending nerve impulses to the muscles in your hand, telling those muscles how to move. The muscles contract, they pull on tendons, which pull on the bones, which allows you to actually move. So this is a cooperation between your nervous system, your muscular system, and your skeletal system, all sort of working in unison. We'll start by talking about the skeletal system. So our skeletal system is made of bone. There's 206 of them. Many of them are in our vertebrae, which we talked about, that protect our spinal cord. Many of them are in our feet, in our hands, in our wrists. That's where lots of the bones are. This should say foot, 26 in each foot, not in food. And our bones basically give our body its shape. They give it its structure. The shape of our bones allows us to stand upright. Some of our bones also are important for protection. For example, our cranium, our skull, is a protective bone. It protects our brain, which is obviously a vital organ, from any damage. Our rib cage, our sternum, protects our heart and our lungs. So some bones form a protective shield for our important organs. And they also provide a place for our muscles to attach. Our muscles pull on our bones in order to allow us to move. Bones also store minerals that our body can take from and store minerals back, such as calcium and phosphorus. So if we have a deficiency of those minerals, our body can get them from our bones. Our bone is actually living material. I know sometimes we might think of like our bone as like fingernails or hair. It's just like a non-living, tough structure, but actually bones are living tissue. They have cells in them which produce new bone tissue. There's blood vessels that run through our bones. There's nerves that run through our bones. And then the hard part of the bones are that make them rigid are things like calcium phosphate, calcium carbonate, calcium-based compounds that give them their strength. If we look at what our bones are made of, in this little pie chart, most of our bones are calcium. That's the largest. Then phosphate is the next. So most of our body's calcium is actually stored in our bones. A bone itself, it's not just like a solid piece of white, hard calcium. It has parts to it. Inside of long bones are some material that's called bone marrow. You might see bone marrow if you break open the bone of a chicken wing or a turkey leg. Or if you eat a steak that has a bone in it, you might see inside of that bone is this sort of fatty red material. That's bone marrow. And that's a living part of the bone. And that's where our blood cells are produced. And the long bones of our body are is this bone marrow, and that's where blood cells are produced, and then they migrate into our actual blood vessels. There's also yellow marrow, which is mostly fat. It's found in the long bones. Also helps in producing blood cells. The outside of our bone is actually has a layer around it, a membrane called the periosteum. And this is where there's lots of blood vessels, there's nerves there. This is where tendons attach to the outside covering of the bones. Inside our bones, they're made of a bunch of specialized cells called osteocytes. And then through these bones are these canals where blood and nerves can go. So we can see a sort of image of a bone here. Probably you may know if you've been to the doctor recently, they may have, or if you had an x-ray recently, you may talk about growth plates. Growth plates are these areas. In an x-ray, you can see a bone here. This is the humerus. Or I'm sorry, this is the radius. And you could see this little sort of gap there. That's a growth plate. That's where this bone will grow from. And so when a person's growing, their growth plates are not fully fused, and that's why they keep growing. If you go and get an x-ray, typically a doctor could probably tell you if you're going to keep growing, because they can see, are your growth plates closed? Have they fused together? If so, you probably are done with most of your growing. If they're still open, it means you probably still are growing. Here's what bone tissue looks like. You can see these are individual cells within the bone, okay? And they have running through them these canals where nerves and blood vessels and so forth are. Our bones have names, anatomical names. Someday you might have to learn them all. We don't have to learn them all, but if you go into any sort of medical field, physical therapy or nursing, things like that, probably one day you might have to take human anatomy as a course in college or nursing school. And in that course, typically you have to dissect a human, really, and learn all the parts of the body, expose them all, understand how they're connected, name them all. That's a typical process for people that are going into healthcare related fields usually. And usually it takes like a whole semester to go through that process, or maybe even 2 semesters. So the bones have different names, and we can see how they're all sort of connected to each other. Where 2 bones meet, we call that a joint. And so you have an elbow joint, obviously, a shoulder joint. Okay. You have your neck is a joint. And there's different types of joints that the purpose of joints are they allow for movement, right? They allow for motion at a junction between 2 bones. There are some bones that are called fixed joints or immovable joints. You could see them here in the skull. You could see this kind of zigzag line on this model. The cranium is actually made of several bones. But as a person, as a baby gets older, they sort of fuse together all into one solid piece. But really, there's several bones. The junction between these is called an immovable joint. Sorry, I lost his eye. Stuck eye.
So cute.
So these are immovable joints. If you ever had like a sibling or a cousin, a baby, you may know when they're first born in their first few months, what's in the top of their skull?
Soft spot.
Yeah, a soft spot. Because these plates don't fully fuse for a while, for several months. And so you can actually see this in a baby if they don't have any hair. You can even see it pulsing up and down with their pulse sometimes. It's just this gap where the bone hasn't fused together yet. And it's to allow the brain to continue growing after they've been born, and then eventually it fuses together. In fact, if it fuses together too early, that's a problem. And they might have to do something to help the skull continue to open up to allow for growth of the brain. So those are immovable joints. Most joints, however, are what we call movable. They allow for motion. So one type of joint is a hinge joint. Like, what's a hinge on a door? Yeah, the things that allows the door to, a hinge on this door allows it to swing, allows it to move. You can see the hinges are here, but a hinge only allows the door here to go this way. I can't tilt this like forward or back or up and down. It only allows for movement in one plane of direction. The same is true of our joints. There are hinge joints. Your elbow, you can only bend your elbow if all is normal in one plane of motion, right? You can't move your hand like left and right from your elbow. It doesn't work that way, right? It just bends up and down, right? When you do that, am I bending at my elbow here? No, I'm moving my shoulder. If you hold your shoulder still, you can't bend just your hand left or right. Like, it doesn't move left or right. It only goes up and down. Same thing with your knee. A healthy functioning knee only goes forward and backward, right? You can't like bend at your knee and move your ankle left and right unless things are really bad. So those are hinge joints. Your fingers, these middle joints on your fingers, you can move your fingers, you can bend them like straight up and down, but not this way and that way, unless you dislocate it. Other joints give a wider range of motion. They're called ball and socket joints. Your shoulder can go up and down, left and right, can rotate as well. That's called a ball and socket joint. The way it functions, the top of the humerus has a little sort of round structure that
Could you say that again?
No. That fits in a little cup of the scapula that allows for this wide range of motion. Let me show these videos. So this shows, these are x-rays of an elbow joint. You could just see it. You could see that the end of the elbow of the humerus is round and it fits in this cup. And so it just bends up and down. This one is the shoulder, and you could see more clearly. You can see the ball of the humerus inside of this sort of cup. Just the anatomy of those things allows them to move differently. Pivot joints are one bone sits on top of another, and they can kind of glide on top of each other or move or sort of rotate on top of each other. Okay, we have pivot joints in our wrists, which allow for like really complex motion, in our skull as well, in our ankles. And then we have gliding joints, which are like our vertebrae, one stacked on top of each other, and they can kind of rotate on each other a little bit. In our vertebrae, like each bone can move a little, and when you add all those up, it allows us to sort of twist and have that twisting motion from our vertebrae. Okay. Here's just an example. This is at the top of our neck. This is the pivot joint, which has sort of a complex anatomy that allows for a wide range of movement. All right, so that's our bones. We also have cartilage. Cartilage is of a strong but flexible connective tissue. Your nose is made of cartilage. Your ears, they are made of cartilage. So it's like flexible, but it's still strong. It provides flexibility. We have cartilage connects our ribs to our sternum because when we breathe, we need some flexibility for our chest cavity to expand. So our ribs have some cartilage at the ends that allow that flex. If this was just solid bone, there wouldn't be any flexibility. You know, when you breathe in, your chest cavity expands, and the cartilage is what allows for that to happen. Also, our cartilage is a cushioning between bones. This, for example, this is, what joint is this? This is a knee. Yep. Okay. And so this is the femur I'm holding on to. So if you look on this little blue kind of disc, this is cartilage that it cushions because every time we step, our femur sort of puts force on the tibia. And so this blue cartilage helps to cushion that. An example of that is our meniscus. So this is called the meniscus. There's a medial meniscus and a lateral meniscus. I tore my meniscus when I was playing soccer. And if this tears, so it tore and it hurt and it was just painful. I couldn't do what I wanted to do. So I eventually went and got surgery, like arthroscopic surgery with the scopes. And they just basically removed it. Because when it tears, it kind of flops in there and it gets caught and it's tight or hurts, it's painful. That's a meniscal tear. If you're young, it might heal. If a person tears their meniscus, it might heal. But as people get older, they lose blood flow to their meniscus and it doesn't heal. So they should get rid of it.
They don't
No, they don't repair it. Nope. And so this, every time you step, your meniscus is cushioning that. So what they told me is that you can still keep being active, but there's a higher chance you might develop arthritis in your knee at some point when you get older. Because now with less cushioning there, every time I step or run or whatever, jump, there's more impact. And that could lead to inflammation, which is what arthritis is. So that's the meniscus. They're basically at the ends of all of our bones. Our nose, like I said, cartilage. And as we grow, an embryo, a fetus, even a newborn baby, lots of their bone is actually is cartilage. And over their time as they mature, it kind of solidifies or hardens into bone as minerals are deposited. So it's much less likely for like a child or a baby to break a bone because they still have a lot of cartilage that provides more flexibility. But eventually it becomes bone as they grow. Oh, and you can see on that little animation on the lower right, left, that red is the cartilage that connects the ribs to the sternum, allowing for breathing in and out.
What's the bone like right by here? It's like sticking out.
Where is that?
It's like right.
Oh, I don't know what that is.
Is that like part of the jaw?
No, I don't know what that is. That's weird. Is it on this? I don't know. It might just be a glitch in the animation. All right. Those are bones. Muscles. Muscles are specialized tissue, and some muscles are under our conscious control. Others are not. Smooth muscle is a type of muscle tissue that's involuntary. It just contracts on its own. For example, in our intestine, to move the food through our intestine, we don't have to voluntarily I better move those Fruit Loops down a little bit lower in the small intestine. We can't do that. We don't have any control over our small intestine or our stomach. We don't have control over some muscles in our body. And so there's smooth muscle tissue. There's also cardiac muscle tissue. It's a special type. It basically is found only in the heart, and it never gets tired. Right? Most muscles get fatigued over time, not cardiac muscle. The muscles that we voluntarily have control of are called skeletal muscles. our nervous system connects with them so that our brain can tell them when to contract and when not to contract. And as we use our muscles, as we talked about at the beginning of the year, because of the buildup of waste products, our muscles can get tired, they can get fatigued, and it's more difficult to actually use them. Here's what the different types of muscle actually look like. These are microscope slides. Smooth muscle tissue that makes up our digestive organs, that's involuntary. Cardiac muscle, also involuntary. And then skeletal muscle, which we do have control over.
Mr. Gross, how does the cardiac muscle not get tired?
It's just, it's a good question. I don't know. Because it has that flow of blood to it to remove waste products and has a constant source of oxygen, I think that's helpful. And the cells are probably adapted to not producing as much lactic acid and waste products. But that's a good question. I don't exactly know the answer 100%. And then we have connective tissue, tendons and ligaments. Tendons and ligaments connect different parts of our skeletal muscular system. Tendons are what attach our muscles to our bones. There's probably one tendon in your body that you can name.
Achilles.
Yes, Achilles tendon.
Oh, that's like your...
It's in your, it's the back of your foot. It's your back of your heel. So like if you touch like above where your shoe is, like behind, like it feels like bone. That's how like tough tendons can be. That's actually not bone. It's actually a tendon. Your Achilles tendon is in the back of your foot. It connects your heel to your calf muscle. So when you contract your calf muscle, it pulls on your Achilles tendon, which pulls on your heel, which points your toe down. That's what your Achilles tendon does. If you damage your Achilles tendon, sometimes like in athletics, people rupture their Achilles tendon. It's really painful. And you have to basically be in a cast. You can't walk on it. You can't use your foot really. And it takes a long time to recover from a rupture of the Achilles tendon, damage to it. Tendons are very tough tissue. They're fibrous. And like we said, our muscles don't directly attach to our skeleton. Our muscles attach to tendons, which attach to the skeleton. So your muscle pulls on the tendon, and that pulls on the bone. You also have all these, your arch of your foot is made of all tendons. And some people get inflammation there, could get plantar fasciitis. If you're a runner or something, you may have heard of that. Okay. These, so if we think about tendons, this is your patellar tendon. This is your kneecap. Okay. And your muscles connect to this to allow your leg to bend. You're at your knee. You could feel your patellar tendon too, right in the front of your. If you bend your knee right below your kneecap, that strong material is your patellar tendon. You could feel the tendons on the back of your knee too. Those like stringy things that when you bend your knee, they pull on the bones and muscles.
How easy is it to like tear?
It's not easy because this material is really tough. They do tear. You can like damage your patellar tendon. You can have inflammation. You ever see people sometimes in sports, they might have like soreness in their patellar tendon. They wear like a little strap right below their knee when they're running. That's usually to help stabilize that patellar tendon. And then we have the ligaments. Ligaments are a tough tissue, again, connective tissue. They hold our joints together. So ligaments hold our joints together. So you could see some ligaments inside of this knee. What is probably the ligament you can name? ACL. The ACL is up here. It's the anterior cruciate ligament. It's inside of your knee, like you can't even see it. It's in here, and it connects your knee together. it stabilizes your knee. Every time you sort of run and plant and pivot, your ACL inside of your knee keeps everything in line because of that force that you're exerting on it. Sometimes people can damage that, right? This year on my soccer team, 3 different girls tore this ACL. And so if it gets torn, then you can have surgery to try to repair it, but it takes a long time to recover. You have to have surgery, and then it takes 6 to 9 months of rehab before you can be back in athletics. There's other ligaments, and you can see them here that stabilize the knee and just hold everything sort of together. You have ligaments. If you know baseball, you have an elbow ligament, the ulnar collateral ligament, and it can be damaged by overuse sometimes. Like in some baseball, there's like pitch counts to limit how many pitches a pitcher throws because overuse of the UCL, like when you throw a curveball, you put a ton of pressure on that ligament, and it can, over time, it can tear, and then you have to have surgery to repair it. So that's why they have pitch counts to limit how many pitches kids throw, so that they don't damage this ligament. Any questions about any of those? All right, last is some malfunctions. So what are some things that can go wrong with our muscular skeletal system? One issue that happens is when bones lose their density, because of calcium deficiency or other reasons. Here's normal bone tissue. Here's bone tissue of a person with osteoporosis.
Is that the same spot?
It's the same spot. So obviously, this bone is much denser and is much stronger. A person with osteoporosis can more easily break a bone. This is also often women experience this as they get older. After menopause, there's hormonal changes in a woman's body that causes her sometimes to lose calcium, and the bones can become brittle. Things like calcium in the diet, doing weight-bearing exercise can increase bone density. So there's things people can do to prevent this. Arthritis is when the joints get inflamed and they're painful to use. Again, this is something that often happens later on in life after some of these connective tissues like the meniscus have been damaged, and then through overuse they can get inflamed. Sometimes the little areas around joints can get inflamed and lead to bursitis, or tendons can become inflamed, and that could lead to tendonitis. These are all basically inflammation of different parts. Bones can be broken, obviously. So a fracture is a damage to the skeletal system, but bone tissue heals really well. If you've ever broken a bone, after you cast it, after several weeks, it's basically back to normal. It's fully functioning after it heals.
Do you always have to reset the bone after you break it?
No, it depends on the position. So if you fracture a bone and it's just cracked, you don't have to have it reset. They probably just cast it. But if you've broken a bone and it's displaced, right, then you can't just cast it because it'll heal like that, but it'll be deformed, right? If you were to break your tibia and it was out of alignment and they just cast it, it might heal and be solid, but then one leg's going to be shorter than the other. You have difficulty walking and running. So resetting means they get the bones back into alignment so that they can heal properly. Sometimes they can't do that. Sometimes they may have to use screws or pins and hardware to keep everything in alignment while it's in the process of healing.
They remove the screws and pins?
No, typically they stay in. I mean, it depends. They can use screws in your body that stay in you forever, or sometimes they have pins that come out of your skin, actually, until it's healed, and then they do remove them. You could have joints replaced. My dad just had both of his knees replaced. He had a lot of pain. He could hardly walk after a while. So basically, they saw off They do surgery, saw off this bottom part of the bone, and put a metal replacement on. And it's painful to recover from that, but once they do that, you have better mobility, better function. How many people have broken a bone before in their life? I never have. Not many. Okay. Any questions about the muscular or skeletal system? We're going to see all of these different tissues in a